Hi, I'm Zach.
And I'm Richard.
This is KinderArm, an extensible and component-based infant transradial prosthesis that increases the product's useful life and reduces the amount of replacements needed.
Prosthetics are designed well for adults. Adults with limb deformities are fitted for prosthetics, and those prosthetics are functional to the patient for a few years until they need to be repaired.
Prosthetics get a lot more complicated with children. Children with limb deformities are fitted for prosthetics, and the prosthetics function well until the child grows and changes. Then the child needs to be refitted for a new prosthetic, which can get very expensive.
Enable, Ambionics, and Hero are all well-known companies that are similar to what our goals are for this project. We identified what was missing from these popular choices with children's arm prosthetics and allowed that to define our design criteria. This prosthetic must be extensible, a component-based system, provide parental satisfaction, and help acclimate the child as early as possible.
KinderArm helps provide children with transradial amputations from as early as 6 months up to 5 years. This is possible by providing a component-based prosthetic for these children. The first component is a replaceable hand to adapt to specific needs. The second component is an extendable forearm that can lengthen to the appropriate size. The third component is the replaceable socket. And the fourth component is the armband.
Working with prosthetic specialists Andrew Lerman, Lauren Rossi, and Joe Kirsch, we researched the growth rate of children and found that children's arms grow a few inches longer over the course of their first 5 years, and this change renders previous prosthetics useless after only a year or even within a few months. What we learned was that in order to reduce the amount of replacements needed, the prosthetic needs to extend a few inches. The diameter of children's arms was not as much of an issue. We explored various options for extension. After developing a simple way to extend, the prosthetic needed a way to be adjusted and lock at the appropriate length.
We explored a variety of different mechanisms that would adjust the length and lock it securely for use. We developed a mechanism that would both fine-tune adjust the extension aspect as well as ensure the prosthetic will not adjust on its own over time. By turning a bolt hidden in the socket, a prosthetic specialist will be able to adjust the length while the patient is visiting. The mechanism can be utilized in other features of prosthetics for lengthening. We developed the prosthetic over a few generations to be very secure and tight-fitting by adding slots necessary to ensure the extension would not rotate on its own. Working with Eric Schneider, our material and processes specialist, we explored how this mechanism is going to be manufactured and assembled. Injection molding these components with polypropylene will allow the prosthetic to be lightweight, inexpensive, and scratch resistant. The socket is overmolded silicone casted in the cup that snaps into the forearm. This is replaced with a new insert as the child's residual limb changes form. When the prosthetic specialist believes it is time to change the socket, instead of getting an entirely new prosthetic, the only part replaced is the socket insert.
The socket insert is a special fit per patient through a 3D scanner, which prints a model of the limb. This is inserted into a mold that then casts the silicone to produce the appropriate socket shape and then fits right into the forearm.
Here we are testing the silicone insert. After developing the internal components of the forearm, we looked at possible forms that this would be and finalized the forearm as a whole. Overall, the forearm is made up of 4 components: the wrist extension, the shell, the extension insert, and the socket insert. The wrist extension moves by a threaded insert embedded inside. The threaded insert is attached to the extension insert. Inside the extension insert is a bolt, split washer, and a self-locking nut. These parts fit securely inside the component. By rotating the bolt, it extends the wrist extension. The socket insert fits into the extension insert with removable snaps that allow for replacement sockets. The shell is attached by being ultrasonically welded to the extension insert.
The hand on the prosthetic also needs to adjust as the child grows. And arm dynamics and large amputee organizations suggest that the infants begin using a prosthetic with a hand that does not function, and then as the child ages, uses slightly more complex hands. Joe Kirsch from Hanger Clinic suggested that instead of designing hands ourselves, simply utilize a company that has already perfected interchanging hands and incorporate their hands with our design. TRS is a prosthetics company that provides a variety of different hands for infants with standard connections. We adapted the prosthetic to include the attachment bolt that TRS Prosthetics uses with their product. This allows for the hand to change out to more sophisticated hands as the child grows. Working with the pediatric orthopedic surgeon, Dr. Renate, we learned that at this age, children with prosthetics have issues regarding overgrowth, which means the bone protrudes out from the skin. This is because there is too much pressure on the residual limb as the child grows. We can combat this issue by transferring the pressure from the limb to the bicep.
We explored a variety of different ways we can remove pressure from the limb and transfer to the bicep. We tested various armbands that we can connect to the prosthetic to reduce this pressure. And we tested a variety of armbands that acted more as sleeves on the arm with attaching the band to the prosthetic with snaps. Our final design for the armband uses pressure fit to keep the prosthetic attached to the band, which reduces pressure on the residual limb as confirmed by Dr. Renate. The armband is made of EVA foam, brushed knit polyester, and a boa fastener, which is a common way that prosthetics are secured to limbs.
Our product is designed for children from 6 months up to 5 years because children need to learn from as early an age as possible how to use a prosthetic to get them comfortable with one later in life. Parents will attach the prosthetic by sliding the armband onto the arm, securing the limb in the socket, wrapping the band, and tightening by turning the boa fastener. The prosthetic needs to be simple to attach as it is very important for hygiene to remove it daily.
We can reduce the amount of prosthetics replaced by allowing for different aspects of the prosthetic to adjust or get changed out if broken or outgrown.
For our next steps, we would love to test this out. We have not been able to test this on a child because of IRB forms. Our next step is to fill out these necessary forms and work with a children's hospital to test on a child patient. These tests will take the necessary steps to understand this product's useful life and make the necessary changes from the testing. Thank you.